Hello everyone, welcome to the training session of the technical support team. The first content we want to introduce to everyone is lubricant theory, also the first chapter. The presentation will consist of two main parts, definition and classification. In the classification will include three parts. The first part is the common types of friction. The second part is what causes friction. And the last part is the synthesis of lubrication principles. First, we go to the first part, definition. When an object moves on the surface of another object, there will be a resistance force created, preventing the motion of the object itself. That force is called frictional force. This force resists the relative motion of solid surfaces, layers of liquids, and particles of matter sliding over each other. Friction is defined as the force resisting the relative motion of solid surfaces, layers of liquids, and particles of matter sliding against each other. For the machine to work efficiently, it is important to reduce the friction between the two surfaces. Next is abrasion. Abrasion is the deterioration of a material on a surface by friction, which occurs reliably and consistently. To improve product quality, it is important to minimize wear in the machine. In many different cases, the force of friction is very harmful, for example, but converting mechanical energy into another form of energy, heat energy turns into mechanical energy. To overcome it requires a lot of energy. When friction occurs, it is to reduce machining performance, reduce tool life, increase defective product rate. In some cases frictional force is also useful as friction force used in brake machines, belt drives. Next is the classification. We come to part 2.1, the common types of figure point friction. There are three common types of point friction: sliding friction, rolling friction, resting friction, also known as static friction. The first is about sliding friction. When one solid body slides over another, the contact surface generates a frictional force, which is called sliding friction. Next is rolling friction. When a circular or spherical object rolls on the surface of another object at the point of contact, a frictional force is generated, called rolling friction. Finally, about resting friction, the force that occurs between two objects in contact tends to change relative to the other but their relative positions do not change. It is called resting friction. 2.2 Causes of friction. There are many causes of friction. The first is about mechanical reasons. Due to the interlacing of protrusions on surfaces that are in direct contact with each other and can only be seen with a microscope, friction will depend on the roughness of the surface. The physical cause is due to the attraction between the molecules of the work surface at the points of contact. Friction here will depend on the points of contact and the contact time. Sliding friction is usually 10 to 100 times greater than rolling friction. The phenomenon of friction always radiates heat, which causes wear of the parts and reduces the effort to resist friction. In the course of research to find ways to reduce friction loss, it was discovered that when surfaces are lubricated with oil, friction is greatly reduced. Under certain conditions, lubricated sliding friction is less than rolling friction. When two moving surfaces are separated by an oil layer, liquid friction occurs, which is the frictional force within the oil itself between the oil molecules. However, the degree of energy loss in liquid friction is still less than in dry friction. Liquid friction has many advantages over dry friction. The machine will greatly reduce the power loss due to friction. The parts are less hot. The friction withstands larger loads and improves the tensile strength and tensile strength. Long service life for working parts. Section 2.3 summarizes the principle of lubrication. According to the Russian scientist Petro has demonstrated that when the shaft rotates in the bearing, the oil layer completely separates the working surfaces from each other and thus prevents the surfaces from coming into direct contact with each other, thereby transferring friction. Drawing between two solid surfaces in contact to form friction with lower energy loss than a lubricating liquid iron. He founded the science of motion in fluids called the theory of hydrodynamic lubrication. Bonding forces between liquid molecules are an important property of lubricants. The greater this binding force, the greater the friction force between the molecules in the liquid. The internal friction of the liquid is the friction created between the moving molecules of the liquid, which is called the viscosity. Viscous. The principles of lubrication of fluids are represented by mathematical formulas. Machine designers and builders can use these formulas to calculate the thickness of the oil between working parts and the cooling efficiency of the oil. Calculations in lubrication theory are mainly used to calculate fluid lubrication retention conditions and oil layer failure conditions, where dry friction occurs, threatening machinery and equipment. The use of lubricating materials in general, grease in particular, and the proper lubrication process for equipment will greatly contribute to ensuring stable operation of machinery and equipment, reducing maintenance costs, advanced age life and accuracy of machinery and equipment. With the reduction of friction in motion, there are other functions that contribute to improving the disadvantages of machinery, such as reducing friction and wear intensity of the contact surface, helping the machine operate smoothly, thereby ensuring the work of the machine. Maximum operating capacity and machinery, cleaning parts, protecting engine and lubricating parts. Anti-wear, avoid sludge formation during operation, reduce maintenance and repair costs as well as downtime when engine and equipment failure. Guarantee the life of the machine. Next, it also helps to dissipate heat, cool the machine and engine, prevent overheating of components, reduce energy consumption of equipment, sealing of engine parts as lubricants can fill gaps that cannot be repaired during machining. It is also a heat transfer solvent in heating systems, is an anti-rust agent that protects metal surfaces exposed to air. To ensure that the lubricating oil can perform all of the above functions, the lubricating oil must be of good quality. Specifically, the lubricating oil must have good adhesion and must be suitable. Must have good chemical properties, good biomechanics, good heat conduction, no chemical corrosion, good cleaning and dispersion of soot deposits generated during the use of engines and equipment. The main requirement of the lubricating fluid is to be able to flow on metal surfaces. Liquids of this nature are very flammable, flowing into the crevices and firmly adhering to the metal surface. On the contrary, it will not be able to flow and enter the small crevices. Selecting the right lubricant is crucial in ensuring that it performs its functions in the best possible way. An important basis for choosing the right lubricating oil is based on the principle of lubrication. In the case of liquid friction, if the viscosity of the oil, the sliding speed of the working parts and their contact surface area increase, the amount of friction loss will increase. As oil consistency increases and parts load decreases, the lubricating strength of the fluid increases. For fast-moving working parts, low viscosity lubricating oil must be used or vice versa. For fast-moving parts, low viscosity lubricating oil must be used and vice versa. The larger the gap between the working parts in contact with each other, the higher the viscosity of the lubricating oil. The greater the load on the working parts, the more dense the lubricating oil must be and vice versa. The higher the working temperature, the higher the viscosity oil should be used. The number of revolutions is large. The working pressure on the small shaft must be used with low viscosity lubricating oil and vice versa. In the range of use with large temperature changes, use oil with good thermal viscosity. Example: high viscosity index, high humidity working environment in contact with air during high temperature combustion, anti-oxidation and anti-corrosion. In the working environment in contact with water and steam, it is recommended to choose an oil with anti-foaming and anti-emulsifying properties. Above is the entire content of the principle of lubrication. Thank you everyone for listening. If you have any questions or concerns, please contact the technical support team or via the below again. Thank you for your appointment. See you in the next content. Bye.